Good day, everyone. This is your regular tutor on the YouTube, Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's topic, I would like that you share this video, you like and you subscribe to it so that it will reach the intended audience. Today, I'm taking us through a topic in mathematics, and that particular topic is on a particular application of combination. So we want to do application of a combination in generating what is called the Pascal triangle coefficients of binomial expansion. So today I'm referring us to the application of a combination. We want to generate the Pascal triangle. Now, how do we do that? We use combination. Like I said the other time, the combination starts from R and N in N, where R is calculated from 0. So the number of coefficients of Pascal triangle using this particular symbol is n plus 1. I will tell us what do I mean by n plus 1 now. Now, for instance, let's say we want to find the coefficient of this expansion. Let's say we have a plus b raised to power 2 case 1, and we have also a plus b raised to power 3. So, in the first instance, the total number of the power is 2, and the total number of the power here is 3. So as we are starting for the first one now, our n is taken to be 2. So if you are taking our n to be 2, then the number n of Pascal triangle coefficients, the number of Pascal triangle coefficient will be 2 plus 1, which is 3. So this particular counter starts from 0 up to n, but our n is 2. So I'm going to write it as up to 2, starting from 0. Then from 0 we move down to 1, up to 2. Then from 1 we move down to 2, up to 2. You see, like the formula I used for combination the other time, this particular 2 combination 0 is same as 2 factorial all over 2 minus 0 factorial 0 factorial. And then 2 factorial is 2. 2 minus 0 is 2 factorial 0 factorial. And then 0 factorial is equal to 1. I'm going to prove it to us later. So what we have here now is going to be 2 factorial means 2 times 1, which is 2. Then times 0 factorial, which is 1. So 2 divided by 2. So this one gives us 1. That's the first case. Then the second case here, 2 combination 1 means 2 factorial all over 2 minus 1 factorial, then 1 factorial. You recall the formula I used for n combination r, which is n factorial all over n minus r factorial r factorial. This formula I've written here is what I'm using here now. So when our n is 2, and we are counting from 0 to 2, so our r will be 0 in this case. So for this one now, using the same formula here, 2 factorial will give us 2 all over 2 minus 1 is 1. That is 1 factorial times 1 factorial. So everything here will lead to 2. That's for that one. Then for this particular one, 2 combination 2 actually means 2 factorial all over 2 minus 2 factorial 2 factorial, using this same formula here. So 2 factorial will give us 2 divided by 2 minus 2, that is 0 factorial, and then times 2 factorial. Like I said, 0 factorial, I'm going to prove it to us after this video. So 0 factorial here is 1. 1 times 2 is 2. 2 divided by 2 will give us 1. So what we have here now is the coefficient of the Pascal triangle. So the coefficients now for this case 1 is 1, 2, 1. That's the coefficient. Now let's go to the case 2 here. In this case 2, our number n, the power n is equal to 3. So Pascal triangle coefficient n is given as n plus 3, which is equal to 4. So we are going to have 4 coefficients. Now, how do we do it? We use this combination, n combination r, which is like I say, n factorial all over n minus r factorial r factorial. So where our n is 3. So and then this r normally start from 0. So we are going to repeat this now in 4 places. So I'm going to have 0 to 3, then 1 to 3, then 2 to 3, then 3 to 3. So for the first case here, 3 combination 0 means 3 factorial divided by 3 minus 0 factorial 0 factorial. So what I have here, 3 factorial means 3 times 2, that is 6. That is 6 divided by 3 minus 0 is 3. So 3 factorial is also 6 times 0 factorial. So 0 factorial is 1. So 6 divided by 6 is 1. So what I have here is 1. Now, we move down to this place. In this case now, our n is 3. And our r now is our r now is 1. So I'm going to have 3 factorial all over 3 minus 1. 3 minus 1 factorial, then 1 factorial. And then 3 factorial, let me create space here. So 3 factorial that we have here is 3 times 2 divided by 3 minus 1 is 2. 2 factorial will give us 2 times 1 factorial, that is 1. So these 2 cancel these 2. So we have 3. Then for the 3 combination 2 here, it means this 3 factorial all over 3 minus 2 factorial, then 2 factorial. 3 factorial as we calculated the other time is 6. 3 minus 2 is 1. 1 factorial is 1. So we have 1 times 2 factorial is 2. So 2 in 6 is 3. Then the last one is 3 combination 3. So in this case now we say 3 factorial divided by 3 minus 3 factorial, then this 3 factorial. 3 factorial as we calculated the other time is 6. 3 minus 3 is 0 factorial. And 0 factorial, like I said, is 1. 3 factorial here is 3 times 2, which is 6. So this 6 that cancels this 6, that is 1. So our answer for this particular coefficient of a plus b raised to power 3 are 1. We have 1 here. Then here we have 3. 1, 3. Then again we have 3 again. Then we have a 1. So these are the coefficients for the expansion of this binomial. For this binomial expression. So now the last thing I'm going to discuss with us is why is it that 0 factorial is equal to 1. Let me just put it in this video. Why 0 factorial is 1. Why 0 factorial is 1? To show that 0 factorial is equal to 1. Let's consider this. Let's consider n factorial. The meaning of n factorial, like for instance, when you say 7 factorial, that means you are going to be, multiplying it in decreasing order down until you get to times 1. So n factorial can equally be written as n times n minus 1 factorial. Now, if n is equal to 0, then I have 0 factorial is equal to 0 times 0 minus 1 factorial. So now, let n is equal to 1. Let's make n to be equal to 1. Yes. So when we make n to be equal to 1, I have 1 factorial is equal to 1 times 1 minus 1 factorial. And the 1 factorial is 1 because we are not going to decrease it. Is equal to 1 times 1 minus 1 here is 0 factorial. So 1 times 0 factorial is 0 factorial. So 1 is equal to 0 factorial. So that's the proof of how 0 factorial is equal to 1. We started from considering n factorial, which is given as n times n minus 1 factorial in decreasing fashion. Then when our n is equal to 1, we substitute. We arrive at this proof. So this is proved that 1 is equal to 0 factorial. Thank you so much for your time. Please do not forget to share, subscribe, like this particular video. I'm at your service. Have a nice day. Bye.